Hey guys, well we are almost to the end of chapter 2, and so today we're going to talk about doing some graphing. Here we go. So the first kind of graph we want to talk about is this. This is what we call a circle graph, and sometimes it's called a pie graph. Now whenever you see a circle graph, invariably you are talking about percentages. This circle graph just happens to represent the different colors of pieces of chocolate candy covered with a candy shell, in each bag. You'll have 30% brown, 20% red, 10% blue, 10% orange, 10% green, and 20% yellow on average. So a circle graph tells us percentages. Whenever you see one, that's what you should think of. And of course the whole graph represents 100%. Each part is like a piece of the pie. The second type of graph is a bar graph. A bar graph usually shows a quantity across a certain category. In this case we're showing the quantity to be density. This is our dependent variable. This is on the y-axis, and our independent variable is the type of material. We have wood, water, sugar, glass, iron, lead, and mercury. Just comparing the various densities of these different materials. So the quantity being measured is always shown on the y-axis, and then the category across the x-axis. And you can use a bar graph to show the comparison between the different items in your category. So bar graphs are used to show quantities, whether it could be time or volume, temperature, you name it. The last type is one you're probably more familiar with, and it's one that we'll use most often in this class. It's called a line graph. In a line graph you have an x-axis and a y-axis. The x-axis is the one that represents your independent variable, that variable that you, the experimenter, are changing. The y-axis represents the dependent variable, what happens from those changes that you make. Here we have a graph that represents the temperature changes associated with various elevations. When you use a line graph, first you have to plot your points. You can carefully plot those points according to your x-axis and y-axis. Once you do, you don't want to connect the dots when you make your line. Rather, you want to form what's called a best fit line, like so. I'm going to take a straight edge and I'm going to place it on my graph so that it's going to come in contact with most of my points, but it might not hit all of them. The line may not hit every point exactly, but it's still a best fit. It's as close as I can get to allow all those to be close to the line. Now I can use this line to perform an interpolation or an extrapolation. Now interpolation is when I'm going to use another point that falls along this set of points right here. Let's say I want to find the temperature at an elevation of 350 meters. That point right there. All I have to do is take a straight edge and go straight up until I hit the line. And then I can take my straight edge and go horizontally to my y-axis. And now I can see that my probable temperature at an elevation of 350 will be around 17.8 degrees Celsius. That's how you interpolate data from a best fit line. An extrapolation occurs when I have to go beyond my set of data points. You have to be really careful when you do an extrapolation. I can be fairly certain of the slope of this line within my data points, but I'm less certain once I get beyond my data points. That's why you have to be very careful with extrapolation. Of course, as you probably remember from math class, I can find the slope of this line fairly easily as long as I have 2 points on that line. I use, of course, the formula for slope. Slope equals rise over run, or the change in y over the change in x. So all I have to do is pick 2 points on this line to find the slope. We'll call this point right here x1 and y1, and this point x2, y2. To find the slope, I take the difference in the y values and I divide it by the difference in the x values. Just for the sake of showing you how this works, I've labeled these points with their x and y coordinates. This one is 125 for my x and 19.3 for my y. This one is 450 for my x and 17 for my y. And I simply plug them into my equation. So I have y2 minus y1, so 17 minus 19.3 over 450 minus 125, x2 minus x1. And I get a value of negative 2.3 over 325, which gives me a final of negative 0.0071 degrees Celsius per meter. Now you'll notice that it is a negative slope, and that makes sense because it's a downward trend, isn't it? As we go across the graph, the trend is downward, so we should have a negative slope. I hope that helps you see how to do that. Hey, can you believe it? We're at the end of chapter 2. That's pretty amazing. Today we talked about different kinds of graphs. We started with a circle or pie graph that tells us about percentages, parts of a whole. And then we talked about a bar graph that tells us about a quantity across a given category. And finally, we talked about line graphs, how to determine the slope of a line graph, and that our line graph has the independent variable on the x-axis and the dependent variable on the y-axis. As always, I hope it's been beneficial for you and helpful. If I can help you in any way, please don't hesitate to come by and see me or drop me an email. Until next time, God bless.